In this new video, we are going to discuss uh, carbon CS fittings actually. So what we are using is a ASTM A850 WPHY fittings. They are high strength wrought iron wrought carbon steel butt welding fittings. It has high yield strength 52,000 psi, and it is resistant to corrosion and hydrogen induced cracking. It is suitable for high pressure applications in oil, gas and water. And what is this WPHY stands for? Road pressure high yield, and 52 indicates the minimum yield strength in thousands of pounds per square inch. So what is this wrought pressure, and what is this wrought iron wrought carbon steel that we are going to discuss now. So what is this wrought carbon steel? It is a mechanically worked or shaped carbon steel while in a solid hot shape. The processes are forging, rolling, and extrusion. Um, Other type is this wrought iron is never cast like this, poured into a as a liquid into a mold. The term wrought refers to the manufacturing process and resulting internal structure like a patent site. So, what is this manufacturing process? Its defining feature is the mechanical working of the metal. It refines the grain size, leading to more uniform and desired set of mechanical properties. And carbon content of the carbon steel is less than 2% by weight. So we have low carbon steel and high carbon steel. So low carbon steel is like mild steel is highly ductile and malleable, conveniently commonly for the general applications like pipes and other pipes and construction. While high carbon steel is used for springs and cutting tool, it is very strong for that reason. And the properties of this wrought carbon steel is that is result in the this working process that is forging, what is saying like forging, rolling, and extrusion results in enhanced strength, toughness, and durability. While the cast iron than the cast iron with a similar composition, so it is less brittle than the cast iron and can be heat treated to enhance its properties. Okay. So it is widely used in applications that require a balance of strength made from formed from the rotor mild steel, low carbon steel, and formed using modern technologies. That is rotor carbon steel. Now, so rotor high pressure carbon steel we discussed. Then the material of the carbon steel. Material of the carbon steel is carbon steel with alloying elements like manganese, nickel, chromium, and molybdenum to enhance mechanical properties. These mechanical properties include the tensile strength, it is approximately 36 KSI or 66,000 psi, and minimum yield strength of 52 KSI. That is this is tensile strength and this is the yield strength. This 52 KS means 52,000. So the tensile strength is 66 KSI and minimum yield strength is 52 KSI. That is 50,000 PSI. Now, what is the dimensions and standards? Dimensions and standard is as per ASME 16.9, ASME B16.28, and MSS SP-075. So, what are the standards that we will see? So, discussing this codes, we have the ASTM B16.9, 16.28, and SP-75. MSS SP-75. These are the dimensions given the manufacture and dimensions of wrought butt welding pipes and fittings. It is used for high temperature applications and high pressure applications. So what is the major difference? This ASME 16.9 is for standard dimensional standard for long radius fittings, and this 16.28 is for short radius elbows and returns, and and for high strength materials, MSS SP-75 is a standard for high strength materials like WPHY grades with stringent testing requirements like Charpy test, impact test, hydrostatic proof test, etc. So, first we need to know what is this long radius and short radius. Okay, we will study it later, but for long radius, we can say that center to face distance is 1.5 d or 1.5 nps, whereas short distance is this center to face distance is short radius is 1 into 1 into diameter. Here it is 1.5 into diameter, it is 1 into diameter. So what is this face to center to face radius? So that we will draw here. This is one fitting elbow. So this is center. It is face. This distance, make it A. This distance is called center to face distance. It is 1.5 d for long radius and 1 d for short radius pipes. So, what the application general industrial piping, this long radius, but high pressure space saving applications for the short radius. And fittings coverage comprehensive range for elbows, tees, reducers, caps, etc. Where this 16.28 meant for short radius pipe, elbows and returns, and comprehensive range for high test machines. This is high test materials for MSS SP-75, and we need to discuss what the size ranges. Okay. So when we are discussing the size ranges, it is 12.7 to this half inch to 48, that is 12.7 mm to 1200, and it is 12.7 to 600, and this is 400 to 1500. So this 400 to 1500 for high test wrought butt welding fittings. It is for short radians, it is maximum to 600 mm, and for this is for a general purpose, that is includes long radius 12.7 to 1200 mm. So that is the details of this ASME 16.9 and ASTM 16.28 and MSS SP-75. Now come back, what is the so this 16.9 is the mainly used standard, comprehensive and widely used standard. It covers overall dimensions, tolerance and ratings and standards. It has this long radius elbows, tees, reducers, caps, etc. From NPS half inch to 48 inch. 48 inch we already discussed. It is 48 inch will be 1200, this one. Okay. Yeah. So that's all. We will discuss further the short radius and long radius also. The short radius is 1.5 into 1 into d, and long radius is 1.5 into d. So this is a center to face distance actually. Length, flow pressure. It is used this short. This is for where the higher pressure drops or turbulence are expected. It's a lower pressure drop and smoother flow. Standard cover is 16.28, and business in some cases entirely primarily covered by 16.9. Choice between SR or LR determine the amount of space available, required flow characteristics, minimizing erosion or pressure loss. Short radius is used where there are the constraints of space, low priority for fluid efficiency. What is that? Used in situations where slight increase in pressure drop is acceptable, such as because shorter radius have some have pressure drops or turbulence, such as low pressure water systems, utility lines where energy efficiency is not the major concern. In that we can use the short radius, we can reduce space constraint, we can minimize, and minimal erosion. When the fluid velocity is low, which minimizes the risk of accelerated erosion caused by the sharper terrain. If the velocity is large, we cannot use a shorter membrane because there will be more erosion, pipe erosion. So long. In this document, we are mentioning the road pressure high yield. That one we already discussed. I think it is nothing but road means it is describing the manufacturing method using road process, which refines the material grain size, eliminates porosity, and enhances strength, etc. And the what pressure means it is meant for high pressure applications compared to cast ones. Cast ones, it is poured as a liquid in a mold actually. So this one we already discussed, and we will discuss the breakdown of this ASME codes. Okay. So ASME B16.9 is a widely used standard. It's a widely used standard actually. It covers overall dimensions, tolerance, etc. for a vast variety of factory-made but fitting materials. It includes a long radius elbows, tees, reducers, etc. From half inch to 48 inch. 48 inch means around 1200. And ASME B60 16.8 meant for short radius wrought steel pipes. Actually, what is difference between short radius and long radius is that for the long radius, this center to face distance is 1.5 d, and short radius is center to face distance is 1 d. So this short radius is used when the space is a constraint. The standard dimensions, tolerance, ratings, etc. are differs. Are considered superseded by this is superseded by 16.9 in recent years, but reference to it still existed today. So now we are using 16.9 only. Now what is MSS SP-75? It is the standard practice, like a code of practice. This is standard practice by Manufacturers Standardization Society. MSS means Manufacturers Standardization Society. It is tailored for the high test, high strength rotain fittings, and it is used for where the primary focus on shrinkage material specification of chemical composition, heat treatment, and extensive testing like a Charpy, which is not toughness and hydrostatic, that is impact test actually, and hydrostatic proof testing, etc. It is high pressure oil and transmission pipelines, etc. So if it is a smaller size fittings like NPS 14 and smaller, we uses ASME B16.9. Okay. So here we are discussing short radius and long radius. Long radius, we this center to face distance is 1.5 d, and here center to face is 1 d, where length where we are using this long radius covered by ASTM B16.9 and short radius covered by B16.28. Now she is superseded by most of the this part is superseded by ASTM B16.9. So what is the choice? Choice between these two is lies in the where there is a space constraint and a low priority for flow efficiency and minimal erosion. That is for the short radius. We are using it where there is less space and lower priority for flow efficiency. That means uh, if there is if a slight increase in pressure drop is acceptable or turbulence is acceptable, such as low pressure water systems, utilities lines. In these things, energy efficiency is not a major concern. So, in this area, we can use short radius pipes and minimal erosion. Minimal erosion means where the when the fluid velocity is low, it minimizes the risk of accelerated erosion caused by the sharper turn. So, this condition also we can use short radius elbows. For the long radius elbow, we are using high pressure and high velocity system because we require a smoother and a gradual change in direction. It can minimize fluid turbulence, reduces pressure loss, and significantly lowers the risk of erosion. And critical pipelines, essential for critical applications like oil, gas, transmission, etc. Water also, where the system efficiency, structural integrity, and the longevity are paramount. And the piggable lines means sometimes pipe need to clean the using pigs or pipeline inspection gauges or devices as larger radius analysis for navigate the tent smoothly. So that is the difference between short radius and long radius elbows. So nominal bore. What is this nominal bore? It is a 120 nominal bore is the approximate diameter in inches. NB stands for nominal bore on NPS. It is a standard industry term used to determine size of the pipe based on this internal diameter. So it 120 inch is a internal diameter. It is saying. It is mentioned in the it is available to up to 120. It in piping industry nominal bore and normal size provides a standardized reference number. So it is a standardized reference number of consistently ordering and fitting the components together, even though the actual internal size will vary depending upon the pipe wall thickness that is scheduled. But so all these are now superseded because we are considering here large diameter pipes. Okay. Now we need to discuss uh, the wall thickness. It is available in various schedules, including Schedule 1, 40, 80, XS, double, extra, extra thickness, double extra thickness. Extra strong and double extra strong, like this. So, what is this meaning? So, for that, what we need to understand what is the schedule. A schedule say Schedule number determines the wall thickness of a pipe for a given NPS or NB. So it is roughly calculated based on the approximation of the pipe's internal working pressure rating. Higher schedule number means higher thickness, more thicker walls. So excess is the extra strong. Modern equivalent is that schedule extra strong is exactly with the schedule 80. The purpose is that increased durability and water capacity compared to standard schedule 40. So these standards are standard X and double X and all are older. We have more precise schedule system is there, like a schedule 40, 60, schedule 180, 160, etc. It is more preferred actually. So this is the standard weight excess and double extra strong. It is modern schedule numbers are schedule 40, schedule 80. So finally, what we are discussing, the schedule number is determines the wall thickness and nowadays we are using schedule 10, schedule 40, schedule 80, schedule 160, etc. These are the older types, extra strong, double extra strong, etc. So these dimensions of a double extra strong pipe is not explicitly defined in a newer standard tables like ASME B16.10. So engineers must refer to the other dimensional tables or manufacturer specifications, as thickness can vary more significantly at larger diameters. So another aspects of this one is heat treatment. Fittings are subjected to heat treatment. So what is this heat treatment? That normalizing, quenching and tempering or stress relieving. What we are going to discuss now. So this heat treatment involves methods like normalizing, quenching and tempering. They are the different types of heat treatment. They are used to purposes to alter the metal's internal crystal structure, so that which will modify the its physical properties like hardness, strength and toughness. Now what is normalizing? It's a it is simple. It's metal is heated to a high temperature above its critical temperature range, then allowed to cool slowly in a still in a still layer at room temperature. So it will become tougher, more consistent in structure compared to untreated steel. Okay, so it's a common heat treatment process to make a metal structure more uniform and relieve internal structure. These stresses are built up during the manufacture process, like rolling or forging. So rolling or forging manufacturing process, internal stresses are there. It had to be relieved and make metal structure more uniform. So this is the we are applying the normalizing method. It is heated to a higher temperature above the critical temperature, allowed to cool slowly, and then it will become more tougher and more consistent in structure compared to the untreated steel. Okay. So now we discuss quenching. Quenching is a rapid cooling process. What we will do? It is heated to high temperature, then plunged quickly into a cooling medium like water or oil. This cooling medium freezes the internal structures into a very hard but brittle phase called martensite. So what is martensite? It is a phase where the metal is very hard but brittle. So it results in high hardness and strength but also increased brittleness. The quenched steel usually too brittle for most applications and requires the next step like tempering. So what we have done it's a rapid cooling process. This quenching, what we are doing, we heating it to a higher temperature than the and then quickly plunged it into a cooling medium called like water. This rapid cooling freezes the internal structure and into a very hard but brittle phase. This phase is called martensite. This is extremely hard and this material will be have extremely hardness and strength but also increased brittleness. So quenched steels usually is too brittle for most applications and requires the next step called tempering. So now we will discuss tempering is a essential follow of to quenching. It is done to increase the toughness and the ductility and make it less brittle while still rating a good level of hardness. How it is done? It is reheated to a specific temperature much lower than the initial heating in the quenching, then held there for a period of time. After that, it is allowed to cool. Exact temperature of this specific temperature determines the a finite balance between hardness and toughness. So, what is difference between hardness and toughness that we have to discuss now. So, difference between hardness and toughness is that uh, hardness is the resistance to permanent isolated surface deformation, scratching or indentation. It is typically measured under a constant compressive load or a abrasive force. Can be measured by indentation test like a Rockwell hardness. So examples of a hard material is a diamond. It is a larger and hardest natural material, but it has a lowest toughness. Means it can shatter under impact. If you take a hammer and diamond may break, but diamond can stand indentations, constant compressive loading, etc. So simple that it is hard. If it is a hard material, it will can withstand the compressive load, but it cannot withstand the impact load. Tough material it can withstand impact load, but may not able to um, withstand compressive load. That is a different. Toughness is ability to absorb energy and plastically deform before fracturing. Typical measured, typically measured use under sudden impact or shock loading. It is measured by impact test. Steel alloys are, for example, it is known for high toughness because it can absorb impact loads and used for application like construction beams, automotive crash frames, or steel pipes, etc. And the brittleness is a very hard material are often brittle. Hard materials are often brittle, but tough material are ductile and can deform significantly. So that's all of hardness and toughness. Okay. Our tempering is done to reduce this brittleness or and make it increase the toughness and ductility. So how it is? It is reheated to a specific temperature, but lesser than the quenching and held for a period of time and allowed to cool. The exact temperature determines the final balance between hardness and toughness. So tempering is done to achieve a balance between hardness and toughness. Result is steel becomes tougher, more resistant to impact loads, less likely to crack or brittle, and the finally tempering tempers the harshness of the quench. Tempering the hardness, reducing the hardness, increasing the toughness. So, what is the cycle? Two-step cycle: heat and cool rapidly to achieve the maximum hardness and brittleness, then reheat gently to add toughness and make it part usable. Okay. So, heat treatment we discussed. Now we go to the. So, what are the main applications for us? We are using it for in the we are using it in the application of this water industry, petrol and chemical industries. Okay. Now we will go to the wrought carbon steel. So we already discussed this one, wrought carbon steel or carbon, high carbon steel. We already discussed. Now we go to wrought pressure. Here wrought pressure. What is this wrought pressure? Wrought pressure is nothing but it is indicates manufacturing method, like using means that refines wrought process is defines the metals grain structure, eliminates porosity, etc., and has its property like toughness and durability, and application suitability. It is for the higher pressure, so that is the wrought pressure. It is wrought pressure. You wrought pressure, the WPHY, high yield 52. That is our pipe fitting grade. Okay. So this one we discussed already. In the next video, we will discuss concentric reducers. Okay. Thank you.